Hello everyone, welcome to Chem analysis. In today's lecture, I will be discussing some selected questions from group theory and quantum chemistry. In quantum chemistry part, I have discussed about some eigenfunction problem, operator related problem and particle in one-dimensional box problem. Later, I will also upload a few more lectures separately on group theory and as well as quantum chemistry from the previous year questions of CSI NET and GATE. In quantum chemistry related problems, I will discuss about perturbation theory and variation method. So for now, let's start this question answer season. The first question was asked in GATE 2013 for 1 mark. It is asked the point group symmetry of alene is among these four which one? Now the structure of alene is like this. These two pi bonds are perpendicular to each other and for that reason these four hydrogens are not in the same plane. These two hydrogens are in same plane and these two hydrogens are perpendicular to this plane since the pi bonds are perpendicular to each other. Now if we set this alene molecule in a cubic box, then these three are the three carbon atoms, and if these two hydrogen atoms remain at this and this corner, then the other two hydrogen atoms will remain in the perpendicular of these two corner, that is in this corner and this corner. These two corners are perpendicular to this corner. Now we have to see that how many symmetry element is expected for this CH2 alene molecule. This is x-axis, this is y-axis and this is z-axis. If you see carefully, then we can see that there is a C2 along the x-axis. If we rotate the molecule along the x-axis, this hydrogen and this hydrogen will interconvert between them and these two hydrogen will interconvert their place within them. Thus there is one C2 axis. Since these four substituents are similar, then we can also think about other C2 axis, that is a C2 plane along the y-axis. Sorry, it will be C2 axis. If we rotate the molecule along this y-axis and if we operate C2 axis, then that C2 axis will move this hydrogen atom, 3 hydrogen atom to at 2 and 2 will go to 3, and similarly 4 hydrogen atom will go to 1 and 1 will go to 4. That means there is one perpendicular C2 axis along y-axis, and similarly there will be another perpendicular C2 axis, that is along z-axis. And if we rotate this molecule along this z direction, then we can see that this 3 hydrogen atom will go to 1 and 1 will come here, and similarly this 4 hydrogen atom will go to 2 and 2 will go to 4. That means there is another perpendicular C2 axis. That means one C2 and its perpendicular 2 C2. For this D2 Chem, since Cn and plus NC2, that means Dn. Now if we imagine, since the structure is drawn in two-dimensional page, so it is difficult to understand, but let's try to understand that this is C2 along y-axis and this is C2 along z-axis. If we see carefully, then we can see that there is two sigma d plane. One sigma d plane will contain these 3 and 4 hydrogen and will pass along this containing these 2 hydrogen and these 3 carbon atom, and will bisect these 2 hydrogen atom, and also the angle between these two C2 axis, that is along like this, and this plane will contain these 3 carbon atom and these 2 hydrogen atom, and will bisect the angle between this CH and CH bond, that is 1 sigma d. And similarly there will be another sigma d plane which will contain 1 hydrogen, 2 hydrogen and these 3 carbon atom, and that plane will bisect the angle between these 2 C2 axis and also the angle between this CH and CH bond. It is sigma d, and the second sigma d will pass and will cut the angle between this C2 axis, and if you imagine it will pass in this direction, that is will cut the angle between these two planes, that is another sigma d. That means we can see that in addition to this there is 2 sigma d, d2 plus 2 sigma d, that means d2d. Thus among the 4 options we can see that the last option is the correct answer. Since there is no sigma H plane, that is no molecular plane, so D2H is not possible. Now let's see the next question. It is asked that the number of C2 axes in CCl4 molecule. CCl4 is a tetrahedral molecule, and if you imagine carefully then you can see that there will be 4 C3 axes passing along each CCl bond. Once C3 will pass along this CCl bond and will migrate this 3 chlorine atom to one another. Similarly there will be another 3 C3 axis along 3 CCl bond. That is, there is 4 C3 axis and there will be 3 C2 axis, and that C2 axis will pass along. If you fix this CCl bond, then one C2 axis will pass along this. Since it is a tetrahedral molecule, any 2 atom will be in one plane and another 2 atom will be on the opposite plane. Let's think that in first side that this 2 chlorine atom is same plane and this 2 chlorine atom in another same plane. So in this case there will be C2 axis which will pass along the middle of this CL angle, and if we rotate this molecule along the C2 axis, this chlorine will go here and this will come here, and these 2 chlorine will change their position. So one C2 axis. Similarly there is another possibility that this chlorine and this chlorine is in same plane like this, and these 2 chlorine are in different plane. In that case there will be similarly one C2 axis, and that will pass along the middle of this CL angle, and if we apply the C2 operation, this chlorine atom will go here, this will come here, and these 2 chlorine atom will change their position. That is another C2, and similarly there will be another C2 axis. In that case these 2 chlorine atom will be in same plane, and these 2 chlorine will be in other same plane, and the C2 axis will pass along this. They will exchange their position, and similarly these 2 chlorine atom will exchange their position. That means we can see that there is in total 3 C2 axis, and we are asked to say the number of C2 axis, that is it is 3. Is it clear? Now let's see the next question. This question came in GATE 2015 for 1 mark. This is very easy question. It is asked the result of operating this operator on this eigenfunction, on this function. Now let's see what happens if we operate the given operator on the given function. it is just simple differentiation, nothing new. So if we differentiate this term, it will be minus ik into e to the power minus ikx. Since differentiation of e term will be e, and further we have to differentiate the power term, that is minus ikx, and differentiation of minus ikx with respect to x will be minus ik. Here is minus. If we bring this term out of the box, then it will be minus minus plus ik h cos square, and again ddx of e to the power minus ikx. And if we and if we differentiate this term with ddx, it will be minus ik into the same term. So if we multiply this, then it will be minus I square k square to h cross square into e to the minus ikx. And if we put the value of minus I square, that is minus 1, it will be k square h cos square e to the minus ikx. It is the result of operating the given operator with the given function. So we can see that among the given option, the first option is the correct answer. Is it okay? So let's see the next question. It was asked about the point group of IF7. IF7, the geometry of IF7 is pentagonal bipyramidal. Since for iodine the number of valence electron is 7, and for 7 fluorine that there came 7 electron, that is 14 electron, that means 7 electron pair, and for that the geometry will be pentagonal. Since there is 7 fluorine atom, geometry will be pentagonal bipyramidal. And if we draw the geometry, there will be 5 fluorine atom in the planar pentagonal plane, and there will be 2 fluorine atom, one is above the plane and one is below the plane. That is like this. Now we have to see that how many symmetry element. Now we have to see that how many symmetry element is present within this molecule. There will be C5 axis passing through this fluorine, iodine and fluorine bond, that is 1 C5, and perpendicular to this there will be 5 C2 axis that will pass along each iodine and fluorine bond. If we operate the C2 axis along this, these two fluorine will exchange their position and these two fluorine will exchange their position. Similarly, when we operate C2 axis along this iodine fluorine bond, these two fluorine will exchange their position and these two fluorine will exchange their position, and in all the cases these two fluorine, due to operation of C2 axis along this pentagonal plane, in all the cases these two fluorine atom will exchange their position. That is, for 5 IF bond there will be 5 C2 axis, and similarly there will be 5 sigma plane along this C2 axis that will pass containing this iodine fluorine and this fluorine bond, and along each iodine fluorine bond. Since there is 5 iodine fluorine bond, there will be 5 sigma V plane that will pass along each C2 axis, that is 5 sigma V plane. And similarly, since this 5 fluorine atom is within the same plane containing this iodine, there will be 1 sigma H plane perpendicular to the C5 axis, and that sigma H plane will contain this 5 fluorine atom along with this iodine, that is 1 sigma H plane. And for this reason, since it is Cn plus N perpendicular C2, these are perpendicular to principal axis, that is D5, and since it is sigma H, it will be D5H. If there is no sigma H plane, then the point group in that case will be d5v or d5d, whatever is the case for sigma. Since there is molecular plane, so the point group must be d5h. So we can say that B is the correct option. Now the next question came in GATE 2016 for 1 mark. It is given that the linear momentum described by the wave function this for a particle is. It is looking like some tricky, but it is not like that. It is asked that the linear momentum, that is px, which is minus I cross ddx, linear momentum described by wave function e to the power minus ikx, that is, if we operate this operator on the given wave function, and if we can transform this calculation in terms of some constant into the same function, then this value will be equal to the linear momentum operator. We have to identify this value. In simpler form, we can say that we have to identify the eigenvalue corresponding to the operator with this eigenfunction. Is it clear? Now, if we operate this operator on this eigenfunction, the result will be, if we differentiate this term, it will be minus ik into e to the minus ikx. It will be I square k h cross e to the power minus ikx. If we put the value of I square, it is minus 1, that is minus k h cut e to the power minus ikx. As I have written this, that if we convert this derivation in terms of like this, that is a constant factor into the function, as I have transformed this in constant factor into the same function, that is the value of this operator is minus k h cut. That is the value of linear momentum operator is this. It is a very simple question, just there is some trick given in the question. You have to identify the trick. So option number D is the correct answer. The next question came in GATE 2017 for 1 mark. It is asked that the wavelength associated with a particle in a one-dimensional box of length L is which of this factor? Here n refers to the quantum number, that is principal quantum number. Now let's think a box of length L, that is the length of the box is L. Now if we think about a wave function like this, suppose a wave function like this, and this wave function corresponds to since there is 1, 2, 3 and 4 nodal plane, that means it is for psi 5, that is here n is equal to 5. Since number of node is equal to n minus 1, here is 4, so n is equal to 5. So this wave function corresponds to psi 5. Now if the wavelength is lambda, then here is involved one wave function 2.5, that is 5 lambda by 2. Is it clear? Since lambda is equal to distance between two maximum peak, that is 1 lambda and another is 2 lambda, and if we sum this one, this will correspond to half lambda. Or in other way we can think that this is a complete wave, this is lambda, this is another complete wave, that is another lambda, and this is half of the complete wave, that is lambda by 2. That means there is 5 lambda by 2, 1, 2, 3, 4 and 5. This all are corresponding to lambda by 2, and so 5 lambda by 2, and this is equal to the length of the box. that means this, and we can write and we can calculate the lambda from here as lambda is equal to 2L divided by 5. Now 5 in this case corresponds to n, since this wave function is for psi 5. So we can put it n in place of 5, that is we can see that lambda is equal to 2L by n. This is the relation between lambda and L for a wavelength associated with a particle in a one-dimensional box of length L. That is, the relation is lambda is equal to 2L by n. Now the next question was asked in GATE 2017 for 2 marks. It is given that this wave function represents a normalized molecular orbital constructed from two different atomic orbitals, phi 1 and phi 2, and these two are orthonormal set. We have to calculate the value of C1. Since this wave function is a normalized wave function, that means we can write that psi into psi star d tau is equal to 1. If we put the value of psi and psi star, we can write that and if we multiply this whole term, then we will get C1 square is phi 1 C1 into 1 by root 3 phi 1 into phi 2 d tau minus 1 by root 3 into C1 phi 2 phi 1 d tau plus 1 by 3 phi 2 d tau is equal to 1. Since the phi 1 and phi 2 forms a orthonormal set, that means phi 1 d tau and phi 2 into phi 2 d tau, it will be 1 and it will also be 1, and phi 1 phi 2 d tau will be 0, and similarly phi 2 phi 1 d tau will also be 0. It is the condition for orthonormal set. So putting this value in this equation, we will get C1 square is phi 1 phi 2, it will be 1, minus C1 by root 3, it is phi 1 phi 2, so it will be 0. It is also phi 2 phi 1, it will be 0. It is phi 2 phi 2, it will be 1. So if we solve this, it will be C1 square plus 1 by 3 is equal to 1. This is 2 by 3. It is C1 is equal to root over 2 by 3, and since it is given the mod value, so the value will be only plus, and if we calculate this, we will see that this value will be 0.81 to 0.82. So the value of mod C1 is equal to 0.82. This question came in GATE 2018 for 1 mark. It is given two operator. We have to identify the commutator of these two operators, where x and px are position and linear momentum operator. Now, from the rule of commutator, we can write it like a. Just we have to put the value of a plus and a minus from the given operator value, and we have to just solve this equation. If we put the value of a plus, that is 1 by root 2 x plus I px. If I forget to give the cap on the operator, then please forgive me. and a minus is 1 by root 2 into x minus I px. Similarly, if we put the value of a minus a plus x minus I px into 1 by root 2 x plus I px, we have to just multiply this two term and it will be x into x square minus I into x px plus I into px into x minus I square px square minus half into x square plus I x px minus I px x minus I square p square. Sorry, if you remove the bracket, then it will be x square minus I x px plus I px x minus x square minus I x px plus I px x plus I square. Sorry, here I forgot to give, it is I into I square, so it will be I square, it is I square p x square. Now this x square will be cancelled out, and this I square px square, I square px square, and this I square px square will be cancelled out, and we can write it like this. It will be 2I px x 2I px x 2I px x minus 2I x px. This 2 is common, so x px. Now 2 is cancelled out. I am bringing this I to out of the bracket. It is px. I am putting the value of px, that is minus IH cross ddx into x minus x into IH cross minus IH cross ddx, that is plus IH cross ddx. Now we have to calculate the value of this term, and we can calculate this value by operating this operator on a function psi and just seeing that what is the result. That is, this operator is written here, that is x IH cross ddx minus IH cross ddx into x, and this operator is operated on a function psi. Just bringing this psi within this bracket, and this is like this, IH cut ddx into psi minus IH cut ddx into x into psi. If we calculate this derivation, then it will be IH cross. Now we have to apply the rule for derivation of a multiplicative term. That is, we have to first keep this psi out of the box, and we have to derive this x with respect to s, and it will be 1, and the x in the second case, x will be out of the box, and we have to derivative this psi with respect to x. Now since this value and this value is just minus sign, so we can cancel it out, so the value is minus IH cross psi. So the remaining value is minus IH cross psi. So we can say that the value of this term is minus IH cross, and if we put this value here, it will be minus IH cross, then the value will be minus I square H cross. Since I square is equal to minus 1, so the value is H cross. So we can see from the given option that Option number C is the correct answer. So that's all for this lecture. I will upload another few videos on quantum chemistry where I will discuss about perturbation theory, variation method and many other important questions of GATE and as well as CSI NET. If you like this lecture, then please share it and please subscribe to my channel. Thank you.